Flack math! Give me some math and I'll give you some flack. Flack math!
All right, we're doing 27 and 28. Just 28 is due next week, so congratulations.
What about practice tests?
We are gonna find no tests coming up.
What?
So here's the triangle.
Yeah.
How do you find the area of the triangle? Let's say that this is our B, our base, and our height. Do you know what it is?
Times our base and height divided by 2.
Okay, divide by 2, because guess what? A triangle, especially this one, is half of a rectangle, but we don't want the whole rectangle by multiplying length times width. We want half of it. So length times width divided by 2. But in a triangle, we don't say length and width, we say base and height. Okay? So the height is how far it is, so it's not one of the sides. Sometimes it is. In a right triangle, it is one of the sides. But a lot of times it's not. So area equals base times height divided by 2. Or you could say area equals 1/2 base times height. Either one works. Even if the triangle is drawn like this, it's still base times height divided by 2. Because you could technically form a rectangle out of this. Okay, so if you put this, if you put another one on top of that like this, right? And then if I took this piece over here, moved it over there, it would still be a rectangle with base and height, right? So it's still base times height divided by 2. That's the biggest thing that you're learning today. Just 1/2 of the base times height, or base times height divided by 2. Okay? Really not too difficult. Sometimes you'll see a triangle drawn like this, which is a little crazy. And this base isn't even inside, or this base is one of the triangle. The base is always one of the sides. I could flip this over and call this the base and then this the height. But if they don't give it to you, sometimes they do it like this, where this is the height. See how the height is not even inside the triangle. But that's still how tall that building is. If this is a building, it's a weird building, but maybe it's a building in Vegas or something, then that's how tall the building was. If I went to the top of this building and dropped a tape measure, it would be that high. If you guys are doing your homework in class, I will not count it towards your Flack attack points.
Okay.
Okay? I don't want you to do homework while you're in class because I want you to listen. So, base times height divided by 2. Either way, you just plug in the numbers. Okay? Do you guys want to do some examples, or does this feel like, let's do some examples. Let's do an example where this is okay, so let's say this is 3 and this is 4. What's the area of this triangle going to be?
Is it inches?
6.
Because of units.
6 units.
Okay, so area equals 1/2 BH. You can always start with the formula, right? So what's B? You can either say it's 3 or 4. If you tip it up on its side, you could say the 3 is the base and the 4 is the height. It doesn't matter. But we're going to say 4 times 3. So 1/2 times 12, or you could say 1/2 times 4 is 2, times 3 is 6. So I'm just going to say this is 6 square units, and it's still measured in square units. Still, how many squares you can fit in there. Okay, what about this? What's the area? Another table, give me the area of this triangle.
20 square.
See, another table means not your table.
Oh.
Oh.
I thought Jordan answered though.
So, spoiler alert, 20. So 1/2 base times height, right? So 1/2 times 10 times 4. So 1/2 40. 1/2 of 40 is 20 square units. Okay? One more. Another table. What about this one? So one of these tables. Outside tables. What do you got? Anybody?
Okay.
One of you three want to answer this? Annie, Chloe, Kale?
24.
Okay, 1/2 base times height, right? Area equals 1/2 times 8 times 6. Well, you could do it like this, 1/2 times 8, just go left to right. That's 4 times 6 is 24. So when you do the 1/2, you don't have to do it in a certain order. You could even go 1/2 times 6, which is 3 times 8 is also 24. Square units, so square inches. Okay, does this feel good? You guys can do this? All right, let's move on to 28.
I like that.
Well, I guess that 10 minutes or like 20 minutes wasted.
Bro, are you doing homework?
He doesn't care about clock points.
Mom's not even letting me.
What about like caring about what I've asked you to not do? Does that matter to you?
Yeah, listening to your teacher, be respectful. That doesn't matter.
Mark, you've done lessons during class before.
Okay, we're going to talk about improper fractions and mixed numbers. So these guys go hand in hand. So basically, proper fraction is anything less than 1. So a proper fraction is anything less than 1. To be less than 1, the numerator has to be less than the denominator. Smaller over bigger. Okay? An improper fraction. Can anyone tell me what an improper fraction is? I betcha you can't get it right. Daniel?
Is it like 13 over 1 or like?
That's an example, but what's a good definition of an improper
The
fraction?
bigger over the smaller.
Okay? Close, but not quite.
Oh.
You're mostly right. What are you forgetting? Do you know what else is considered an improper fraction?
0.
If it's
Negative.
equal to 1. Okay? So you could have like the same number over itself
Bullying.
or bigger over smaller. So like 3/5 is an example of a proper fraction, 5/3 or 6/6. That's an improper fraction. You don't say that. So you don't say, yeah, I had 6/6 of a pizza. You could say, I had the whole pizza.
I have said that though. Not with pizza.
Okay. I guess you would say 4/4, right? I've got 4/4, or it's easier to say I've got $1. Okay. But if you want to know how many coins you have, you would have to say 4/4. But 4/4 is just 4/4, right? Because that's what a quarter is. It's a fourth. Okay. So proper and improper. The best way to explain this is with pizza. So sorry. This would have been a good day for you to bring your
I brought it.
GF pizza.
I brought it.
Did you? Do you want to eat it?
I mean, it needs to be microwaved.
Oh.
Can we bring another pizza if like donuts if we all get a good grade on the next test?
What about this test? Did
No,
everybody get a
'cause
good
then,
grade?
and then people will feel bad if they didn't get a good grade. So here's what I want to do. This is an improper fraction, right? Because it's top heavy. The bigger number's on top, right? So how would I explain this using pizza? How to change this to a mixed number? 10/3. So let's say the pizza were those little personal pans and you cut them into thirds. So how would you explain this? Daniel, do you got a good way to explain it?
I got 3 pizzas and 1 extra slice. Or I have 3 pizzas and each pizza is made out of 3 slices, and I got 10 of those slices, so there's 3 pizzas and 1 slice.
Yeah. So you're basically wanting to know how many full pizzas are in 10/3. Okay. So what do you do to figure that out? Well, how many thirds are in 10? How many pieces are in 10 pieces? How many full pieces? Okay, so we got 3/3 plus another 3/3 plus another 3/3. And then how many do you have left over?
2/3.
1/3. How did you get 2?
Plus 1/3. Okay? So now you don't have to draw pizzas every time, but you know that in the thirds world, what makes thirds a whole? Well, 3/3, right? If it was sevenths, what makes sevenths a whole? 7/7. So you're wanting to know how many 3/3 go into 10 or whatever. So I'm just going to divide by 3. Okay? So this is going to tell me how many holes are in there. It's 3, but then there's one piece left over. There's 1/3 left over. Guess what? This goes up there, and this goes right there on the bottom. So the denominator, when you're going from improper fractions to mixed numbers, the denominator always stays the same. Once a denominator, always a denominator. Okay? But this is right, basically when you do a division, you can, and you have a remainder, you can either write R(1), or you can write your remainder as a fraction, which is what we're learning today. And you guys knew, most of you knew this,
Yes.
but, and really what you're doing is you're dividing 10 by 3, and then you're dividing the 1 by 3. So let's do this. Let's say I've got 12 inches. I've got 12 inches of fruit roll-up.
Let's go.
No!
Okay, and I'm gonna split it evenly between all of us. So what am I gonna do?
3 of us?
Yeah. So how many people are in the class? 1, 2, 3, 4, 5, 6, 7, 8. So let's see. If it's 12 inches, each of you are gonna get 1 inch, right? You're gonna get at least 1 inch. But then what's left over? We have 4 inches left over.
1 1/2.
So we gotta divide that 4 into 8 parts too.
So
1/4.
So 4/8. So we divide the remainder into 8 parts too. That's what we're doing here. When you divide and you get a remainder, you have to take that remainder and divide by 3 as well. Look what we did. The remainder divided by 3. Okay? So that's a nice way to think about it. That fruit roll-up. You got 12 inches of fruit roll-up.
That's a
There's
lot.
8 people in the class. You divide by 8 and you get 1 inch. But then you have a remainder of 4. So that 4-inch remainder, I'm also going to divide that into 8 pieces. So 4/8. Same thing here. If I had 10 inches of fruit roll-up and I wanted to split it between Uncle Kevin, me, and Mrs. Flack, then okay, we would each get 3 inches, but then there would be 1 inch left over, right? Because there's 10 inches of fruit roll-up. So we each get 3 inches, but then I'm going to take that 1 inch and cut it into 3 separate parts. I'm going to divide that 1 by 3 as well. Okay? So that's what it means to write your remainder as a fraction. Just throw it over the denominator. Okay. So this is not too bad. Let's try some examples. You ready? You can probably do this in your head. Let's write this as a mixed number, 14/5. Can you do it in your head? Don't say it out loud if you got it. Okay, raise your hand if you know it already. Okay, we've got 1 or 2 people.
what's the number?
14/5. Okay, so think about it like, let's figure out how many, if it's pizza, how many whole pizzas, if the pizza each had 5 pieces in it, how many whole pizzas can you get out of 14 pieces? You can get 2, but how many pieces are left over?
2 and 4/5.
4 pieces, and in this problem, the piece is a
Still my
fifth.
answer, Jordan.
Okay, so mathematically, we just do this. If you do it not pizzally, but mathematically, we do it like this. 14 divided by 5. Okay, top number always goes on the inside of the box. You just, to change to a mixed number, you just do what it says. This is not just a fraction, it's a division problem. 14 divided by 5. That goes in 2 times with 4 left over. What do you do with your remainder? Throw it over the denominator. 2 4/5. Okay? So you can also do it in your head because 5s are kind of easy to count, right? The next 5 up would be 15, so you don't quite get 3 full pizzas. You get 2 with 4 left over, so 2 4/5. Okay? See if you can do this one in your head. Ready?
My head?
21/8. Can you do it in your head? Are you doing it in your head? So this is actual, like 21 pieces of pizza. Usually pizzas come in 8s, right? They come in 8 slices. So how many full pizzas are in there, and then how many pieces are left over?
16 and 5, 21.
Okay, you got the right idea, but
21.
not 16 pizzas. How many full pizzas are in 21 pieces?
I don't know.
Well, 16, you had the right idea. 16 pieces is how many pizzas. If they are 8 slices apiece, how many pizzas is 16 pieces?
2.
2 full pizzas. So you get 2, and that's 16. And then how many are left over? 5, but not 21st. 5 pieces. Remember, pieces of pizza are 8s. Okay? But that's doing it in your head, Henry. You don't have to. You can just do what it says. Divide. This is a division problem. The number on top goes on the inside of the box. 21 divided by 8, is it goes in 2 times. No more than that. And then you have 5 left over. Write your remainder on top. Right there, 5. And then your denominator stays on the bottom. Once a denominator, always a denominator. If you have a denominator of 8 in the mixed number, you're going to have a denominator of 8 in the improper fraction. Always, unless it's not reduced, but it should be, yes.
Throw this away.
Throw what away?
More.
Oh, I thought you said throw it away.
Time to do.
She did.
We might have some time here. Don't give up on me.
Yeah, right? We don't even need the TV.
Okay, how do we go the other way? How do we go backwards? Well, what did we do to get all that?
You do the opposite, you just multiply.
To go backwards, well, let's start with our original example, 3 1/3. If you think about pizzas, so now we're gonna cut the pizzas and then just collect them, put them in a Tupperware, and bring them to school.
Let's go.
So let's say there was 3 whole pizzas and then 1 piece of another pizza left over. So how many pieces are going to be? Well, if there's 3 whole pizzas, how many pizzas come in 1 pizza? How many pieces come in 1 pizza?
1 pizza.
3.
Pizza.
So 3 times 3. So it's like the equal group problems.
3 times
You're
3
gonna mess
plus.
your hat. And
So 3 times 3
Why do you stop?
plus 1
Where is it?
all over thirds, right? We're still talking about thirds, so it's 10 thirds. Okay?
Yes, sir.
So that denominator is how many, what the fraction is, but then their whole number, this is like you actually cutting the pizza. Okay? Let's say that between the 2 of us, Uncle Kevin and I are gonna eat 5 whole pizzas and 1/8. 5 1/8 pizzas. How many pieces is that? This would be a marathon. Like, I think we could do it, but it might take a couple hours.
How do you buy 1/8 of a pizza?
No, that's what's left over. These are the leftovers from like a party we had, a math party.
How big was
Science
this
party.
party? I thought so much.
Well, we ordered too many. Apparently not a lot of people came to our party, so this is what was left over. Okay?
Blame them.
So how many pieces of pizza? Well, here's what we got to do.
41.
First, we got to cut this into 8 pieces each. So how many pieces is this? If there's 8 pieces in each pizza, how many pieces is that?
40.
Yes, and then plus that 1/8, 1 more piece, so 41 pieces or 41
Okay,
eighths.
that's like $50 on pizzas.
No, that's just the
Okay.
leftovers.
So
It's
basically,
more
it's
like
8 times 5 plus 1 all over 8. So it's 41/8. Okay? So here's your formula. Your denominator, oh my gosh. Denominator times whole number
Chromosome number what?
plus numerator all over your denominator. Okay? So that's going from a mixed number to an improper fraction. Okay? So to go from an improper fraction to a mixed number, it is numerator divided by denominator. And then you get your whole number. And then your remainder over your denominator. You can write this down if you want, but it's a little confusing. But I would recommend writing this down to change from a mixed number to an improper fraction. It's the circle thing. You guys remember the circle thing from last year and a couple of years ago? You guys are probably doing the circle thing for a while. To change a mixed number to an improper fraction, you go in a circle. 8 times 5 plus 1, all, and then end where you started. All over that's where you started. 8. I saw a hand up. Yes.
Can I go to the bathroom?
Yeah.
How much
20
time
minutes.
do we have left in class?
We have 20 minutes left. I'm just going to do 2 more examples and then we'll call it a day. Sound good?
Yes, sir.
We have to like leave school for the rest of the day.
Sounds cool to me.
I'm cool.
You're not that guy, pal.
Yes, I am.
No.
You're just cool.
Okay, let's convert these. 2 1/8, 7 4/9, and 5 3/11. You got all 3?
Oh, where's the third one?
5 3/11.
Where's? Oh, are we also doing 2 1/8?
Yeah.
Oh, I didn't see that one.
But you got the first one?
I got 7 4 and then 5.
How did you get 74 for your first one?
Okay. Who wants to give me this one? Jordan?
17/8.
Okay, so we went 2 times 8 to get 16, and then added 1 to get 17, all over, all the way around, go all the way back to 8. Okay? Somebody else, give me this.
67/9.
So 63 plus 4 is 67, all over that same denominator. All right, who's got this one? 5 3/11. Someone else. Annie, you got it?
57.
58.
58. That's right. You're just off by 1 there. So 55 plus 3, 58.
Now can we work on our homework?
That's it. That's all I got.
Black man, give me some math and I'll give you some flack. Black man.